All right, here we go. Periodic table brain dump. So first things first, we are going to put A, P, E. Remember that this is decoding an atom, so the atomic number is what A stands for. Protons, number of protons. Number of electrons. Remember that the M stands for the mass, which is found here, right? The atomic number is here, so that goes to that. The atomic number again is A, so no neutrons. So that's what we're trying to find, number of neutrons. All right, so we talked about this, the first part of this unit. Now we're getting the second test, which is going to talk about the periodic table. The first thing we talked about was that all of these are metals. So metals are on the left-hand side. They're shiny, they're good conductors, all of the above, right? And then we talked about metalloids. Metalloids are on the zigzag line. This zigzag line, you guys could actually take a highlighter. You can do whatever you need to do, but make sure you understand that on the zigzag line that goes down, remember I told you about the hopscotch. So single, single, double, double, double is how we're going to remember our beautiful metalloids that are on that zigzag line. Then I told you that this over here, carbon over, is going to be your non-metals. Oops, forgot to label my metalloids. I'm doing this as I hold it with one hand and yeah, okay, so. All right, so, and then we talked about groups, okay? So I told you that groups are linked together by their valence electrons. Remember that valence electrons are the outermost electrons that are in charge of all chemical reactivity and chemical bonds. So that means that this is group one, and this right here represents one valence electron. So that means that everything in this whole group right here has one valence electron, and they all are similar in chemical reactivity because of that one valence electron. This is group 2. Group 2 has 2 valence electrons. Now, everything in this column has 2 valence electrons. Everything in this column has the same chemical reactivity. Everything in this they have similarities. It's like groups of friends or your family members. So this can be groups or family number. That's what it's called. So this could be a family. So now we've got our bullies. So I told you to remember this B represents bullies because they do not abide by the rules. So like our bullies do not abide by those rules. So that's there. Now this is group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11, group 12. Now, those are all the groups, but they don't abide by the rules, so they're bullies. So then we skip over to this side of the periodic table, and we learned that this is group 13 with 3 valence electrons. So everything in this group has 3 valence electrons. Everything right here, group 14, 4 valence electrons. And group 15, 5 valence electrons. Then we have group 16, 6 valence electrons. Group 17, 7 valence electrons. Group 18, 8 valence electrons. Now, it is very important that you understand that this right here is the whole goal of all atoms. They want 8 valence electrons. They want to be full. They want that last energy level full. So that shell or energy level, whichever one you want to call it. So this is called noble gases. And these guys are the most stable. That means that they are unreactive. They're stuck up. They're happy. Whatever. However you want to talk about it. They stand alone. They do not have to react. They do not have to gain or give electrons to get back in the groove. They're good. They're happy. Noble gases. Okay, so that's where we're at right now. So if this is the most stable, the unreactive group right here, then this right here, this group, group 1, is the most reactive group. Those are our earth metals, okay? So earth metals. So you need to understand that group 1, these guys are highly reactive. because they only have one valence electron. They want that last energy level full, and they're trying to get it. They will react with whoever, whenever, so that they can get some sort of 8 valence electrons. They're trying to get that last electron level full. All right. Now, these numbers on this side is the period numbers. Period numbers equal the number of energy levels. Okay, so that means that this is row 1, period 1. Row 1, period 1. So hydrogen and helium are the only ones on that row, and they have 1 energy level. Row 2, period 2. Same thing, all the way from lithium all the way to neon, just 2 energy levels. We got row 3, period 3. They only have 3 energy levels all the way across. So even aluminum all the way to argon, 3 energy levels. Then you got period 4. Period 4 goes all the way across. There's 5, there's 6, there's 7. Now you need to make sure you also remember that right here, this right here is where the table splits. So 56 to 57. So that means that this is period 6 and this is period 7. If you know that the periods and everything run across here and that the similarities is because they have this beautiful energy levels, then you are solid. You are good to go. If you understand that groups, columns have chemical reactivity similarities, and that's the reason why they are grouped in columns, then you will understand the test. So you need to take the review, and you need to take this, and you need to study. Good luck.